Okay, so for our last problem, we're going to look at an astronomical issue of detecting a small planet where the star wobbles and gives a small redshift in the direction of the Earth. So in this case, we wanted to detect an Earth-sized planet, something that's going to be small and something that's going to leave the center of mass very, very close to the star in question, thus giving it a radial velocity that is 10 meters per second, which is very, very, very slow. We want to know what percent shift in frequency and corresponding wavelength we would have to be able to observe with our spectroscopes. And a spectroscope is just something that can analyze the light and look at very small changes in the spectrum due to a doppler shift. So the thing you have to be careful here is what we're solving for. We're not solving for a frequency or even a new frequency. We're looking for a shift in frequency. So a shift generally means something minus another, in other words, a delta F. But we also want the percent, so it's going to be delta F divided by the original frequency. Since we have such a small speed of the object, in this case the star, compared to the light that's coming from it, we're going to use our approximation equation, which basically says delta F equals F times V over C. And since we're not solving for delta F, but rather delta F over F, it becomes even simpler. So that's going to be V over C. Alright, when V in this case is 10 meters per second, which is tiny, compared to the speed of light, 3 times 10 to the 8th meters per second. Okay, and this becomes 3.3 times 10 to the negative 8th as a number, and if we multiply that by 100%, we see that this is 3.3 times 10 to the negative 6%. So we're talking a very, very, very tiny shift percentage-wise, but we do have instruments that are able to measure that.